Hello everyone. Today we are going to study about electrostatics. Here these are some topics which are deleted from this chapter for this year. Here this is electric charges, electric field intensity due to point charge in a material medium. Then practical way of calculating electric field, proof of Gauss law, electric dipole, and continuous charge distribution. Actually these all topics, this electric charges, that you have studied in previous standards, so you are aware about it, but just go through it, read it at once, so you will get clear your concepts. So further, let's start for the electrostatics. Electrostatics deals with the static electric charges. Static electric charges, we know the charges positive, negative, and another one is neutral charge. So the forces between them and the effect produced in the form of electric fields and electric potentials, that is nothing but electrostatics. This you have studied in previous standards also. In this chapter we'll study further aspects in details. So everyone knows the current electricity, what it is. So in day-to-day life we have charges, moving charges around us. So that moving charges you will get aware under some special circumstances. For example, in winter, what happens when you will wear any sweater? That sweater, or when you will remove sweater, then due to that dry day you can hear some crackling sound, and that the sweater appears to stick to our body. So this is because of the electric charges produced due to friction between our body and the sweater, right? Same here, from this diagram you can see here, this is the sweater which is giving positive charge, and this is balloon which is giving negative charge. So this balloon will get attract towards this sweater because of opposite charges, right? Same another example which you know, that is lightning in the sky. That is again the example of flow of charges, amount of electric charges that develop on the clouds due to friction. So due to that friction there will be lightning in the sky. Okay, so everyone got that what is the electrostatics, and these electric charges all time around us. Okay, so now further we'll think about basic properties of this electric charge. In that, first one is additive nature of charge. This electric charge is additive, similar to mass. That is, the total electric charge on an object is equal to algebraic sum of all the electric charges distributed on different parts of the object. So when there will be any object, then electric charges in that object present everywhere, positive, negative, that all charges will be additive or will give a common charge, that will be Q, which is addition of all charges in that object. Okay, so it may be pointed out that while taking the algebraic sum, the sign positive or negative of the electric charges must be taken into account. So if two bodies have equal and opposite charges, the net charge on the system of the two bodies is 0. So this is similar to that in case of atoms where the nucleus is positively charged, and this charge is equal to the negative charge of the electrons, making the atoms electrically neutral. So it is interesting to compare the additive properties of these charges with that of mass. So here from this one, that charges are the algebraic sum of all charges of all parts of the object. Now this comparing with the mass, that is, there will be two cases here. The masses of the particles constituting an object are always positive, and whereas the charges distributed on different parts of the object may be positive or negative. We are comparing this electric charges with the mass. The total mass of an object is always positive, whereas the total charge on the object may be positive, 0 or negative. So when we consider the electric charges, we have to think about this 2 points. Then let's study about next point, that is quantization of charge. So here quantization of charge is the minimum value of the charge on an electron as determined by the Milken's oil drop experiment is E equal to 1.6 into 10 raised to minus 19 coulomb. This is called the elementary charge. This is what? Elementary charge, which is shown by small e. C, that is unit coulomb. Unit of charge is defined in this further topic. So since protons, that is positively charged, and electrons, which are negatively charged, are particles constituting matter, the charge on an object must be an integral part of positive negative E. So this quantization Q will give plus minus E. This quantization Q is equal to plus minus E, and there will be number of that charges. So this becomes total number plus minus n into E, where n is integer, which is showing positive and negative signs. So charge on an object can be increased or decreased in multiples of E. So this is because during the charging process an integral number of electrons can be transferred from one body to the other body, and this is called the quantization of charge or discrete nature of charge. So what is quantization of charge? This is during the charging process an integral number of electrons can be transferred from one body to another body. So this is the quantization of the charge or discrete nature of charge. So the discrete nature of electric charge is usually not observable in practice. So it is because the magnitude of elementary electric charge E is extremely small. its value is extremely small. Due to this, the number of elementary charges involved in charging an object becomes extremely large. Suppose, for example, when a glass rod is rubbed with the silk, a charge of the order of 1 microcoulomb. When glass rod is rubbed with silk, then there will be production of the charge which is in 1 microcoulomb, that is equal to 10 raised to minus 6 coulomb, which appears on the glass rod or silk. So this elementary charge E is equal to 1.6 into 10 raised to minus 19 coulomb. The number of elementary charges on the glass rod is given by, now this value we have to put, so it becomes N equal to 10 raised to minus 6 coulomb upon this 1.6 into 10 raised to minus 19 coulomb, which is equal to 6.25 into 10 raised to 12. Since it is tremendously large number, the quantization of charge is not observed, and one usually observes a continuous variation of charges. Everyone got this? What is quantization of charge? It is just during charging process, an integral number of electrons can be transferred from one body to another body. This is quantization. Okay, so this number N which we are getting is tremendously large number. So usually continuous variation of charges will get observed. Then further part is conservation of charge. So as we know that when a glass rod is rubbed with silk, it becomes positively charged and silk becomes negatively charged. The amount of positive charge on glass rod is found to be exactly the same as negative charge on silk. So this is the system of glass rod and silk together possesses zero net charge after rubbing, right? So that there will be zero net charge. So result and conclusion of this experiment can be generalized, and we can say that in any given physical process, charge may get transferred from one part of the system to another, but the total charge in the system remains constant, or we can say it as, for an isolated system, total charge cannot be created nor destroyed. So in simple word, the total charge of an isolated system is always conserved. Okay, so everyone got that? There will be total charge when glass rod which we are considering will give equal charges but opposite to silk material. So there will be net effect becomes zero. Then forces between charges. It was observed in carefully conducted experiments with charged objects that they experience force when brought close but not touching to each other, but brought to close each other. This force can be attractive or repulsive. So like charges attract each other and unlike charges repel each other. So from this diagram you can observe it. When there will be opposite charges, they will attract each other, and when there will be same charges, they will repel to each other. Okay, this is about the electrostatic introductory part. Quantization of charges, then conservation of charges, and forces between charges with the additive nature of charges.